Welcome to React Basics. In this course, you'll be introduced to the basics of working with React. During this module, you'll learn how to develop a working familiarity with the basic structure and use of the React.js library, explore the concept and practical use of state and state management, and discover how to set up navigation and make use of assets in your React apps. You'll begin by learning how to work with React to build modern user interfaces, or UIs, on website front ends. This involves the concept of standalone parts of the user interface, or UI. These standalone bits of UI are commonly referred to as components. You'll explore components in more detail later in this module. For now, it's enough for you to know that every website's UI is built on a foundation of components and composability. Simple components combine into more complex ones, which eventually merge to form a website. So, a website can essentially be viewed as a highly complex component. Components in website UIs are not limited to React, but a part of the reason why React is so popular is because it streamlines the process of building and composing components. React does this efficiently and without a significant impact on your browser's resources. Another major topic that will be discussed in this course is working with state in React apps. You'll learn a lot more about state as you go through the course, but for now, here's a simple definition of state. State is simply all the values of all the variables your app is working with at any given point in time. As you progress through this course, you'll also learn about how to style your React apps, which includes the reuse of common styles, setting up your apps to respond to events such as clicks and user-submitted data, creating navigation routes and using assets, and you'll finish off the course with a portfolio project where you'll apply your new knowledge. I hope you're as excited as I am to begin this course on React Basics. Let's get started.
My team uses React, and we use a lot of new and experimental features that the React team is building. Facebook.com is like a demonstration of all the new and cool features that React engineers are working on. So when we rewrote the website, we were actually using a lot of unreleased features and kind of experimenting with a lot of new things that the React team was building, which was really cool to kind of use it first. My name is Katie, and I'm a software engineer on the React apps team at Meta, and we work on building a variety of new features for Facebook.com. There are plenty of React-based apps that you've probably used before. Facebook and Instagram are two examples, but Netflix, Airbnb, New York Times, and a variety of other companies also use React for their websites as well, so you've likely encountered it before. These websites that tend to have really interactive UIs are more likely to be using something like React. So Facebook.com had become really not performant and not modern looking after the 10 or so years that we had been using it. We had squeezed all of the performance wins that we could out of Facebook.com. So really the only option at that point was to rewrite it on a different stack that was going to be a lot faster and a lot easier to build on. Basically, there was a need for having a really fast and responsive UI, and React fills all of those needs. So this was kind of a shift in thinking differently about how we build on web. We actually rewrote our website a couple years ago to be completely React. And so every engineer who's writing for Facebook.com at Meta is pretty much using React. I was there for the middle of it to finally launching it. So it was cool that a little bit of it was already written and we were getting prepared to show it to real users. I think 40 engineers on our team were all working on building out this MVP of the redesigned Facebook.com. And we would work with a variety of product teams to get them to also rewrite their product on our new stack as well. It was a really big effort, and it was also a really big risk. Not all the teams that we talked to thought that we could ship this new version of Facebook.com. So we really had to prove that it was faster. It obviously looked more modern, but we had to prove that it would really help these product teams deliver the best version of their product that they could on web. So React is open source, meaning that anyone can contribute to it. And those engineers are working full-time on React. But we also have developers who are at Meta who are also contributing to React. And that means that there's a really strong community around React. And a lot of people are really excited to build on it and make improvements to it. So if you ever have any questions or you have an idea about a certain feature or optimization or improvement, there's really like a great opportunity to actually contribute to the React library itself. So there's a React team at Meta, and this team is comprised of engineers who are working on React full-time, but there's also a group of developers outside of Meta who are contributing to React as well. I think the open source part of it is really cool just because there's such a community around React. It's constantly being updated and maintained, and there's always going to be someone available to like answer questions or to update documentation. It's very current. If you're using React for the first time, definitely take a look at our documentation. There are a lot of conversations being had about React online, and we actually have a React conference every year where we talk about new features with React, and you can just connect with a lot of React developers. So there are plenty of opportunities to get involved in the React community, and I think it makes building with React even more rewarding if you kind of connect with the community as well. React is used everywhere in the tech world, and you'll have the chance to use it throughout your career, so it's a very valuable skill set to have. Yeah. My name is Katie, and I'm a software engineer on the React apps team at Meta, and we work on building new features using React for Facebook.com. My first encounter with React was actually in a senior design project back at college. We were looking for a great client-side library to use for an app that we were building, and React seemed like the easiest to use and the fastest to build on. I had already gotten my job at Meta, but I didn't know what I was going to be working on at Meta, so it was cool to kind of get this experience with React, realized I really enjoy working with it, and then get to do it in my day-to-day work. So I feel like in school you tend to do a lot of object-oriented programming, which uses inheritance. React doesn't use any of that. It uses something called composition. So that was a little bit difficult to think about, but there's so much documentation around React and such a strong community that it's easy to pick up, and you have support coming from so many different places. You can just go onto YouTube and watch a video, read through the documentation, or look at other open source projects that use React. So there's so many resources to pull from. I think developers outside of Meta choose to use React for the same reasons that we do at Meta. It's super easy to learn and pick up. You're able to create really custom UIs with React. We're building so many different features on Facebook.com every day that require a lot of custom components and UIs, so it's nice to have the flexibility that React provides. I would say React is the best choice for an app if your UI is really custom and you're looking for a lot of flexibility with what other libraries you can integrate for your app or website. React is just a front-end library. You're going to need to interact with other third-party libraries too. And if you want the flexibility of integrating with Redux or other third-party libraries, React is the perfect choice for you. React is also great if you have complex UIs where you want to reuse code across many different pages. So I think it's a great choice if you're building a complex website with a ton of features across a ton of different pages. I think React solves the problem of code reusability really well. Here at Meta, we have a core set of UI components that we're actually able to reuse across the site. And this means that we're able to build a lot of functionality into these core UI components, like accessibility. I think we're able to have a high quality bar across the site just because we're reusing components everywhere, and we're able to kind of share code even across Facebook and Instagram and Messenger. So I think that's a really unique part of React. It's really interesting because if I find a bug in a core UI component and I fix it, I'm not only fixing it for my one use case, I'm fixing it for use cases across the site. So I think it's a really smart way to use engineering effort. You're fixing a bug once and you're solving one problem everywhere. So I would say the biggest competitor of React is Angular. Angular is a bit different from React in that it's a full-fledged solution for an app or website. You don't really need to integrate with third-party libraries when using Angular, whereas with React, it's just a client-side library. So you do need to figure out how you're going to do routing and server-client communication. I would say React provides more flexibility with creating these complex custom UIs, whereas Angular makes it easier to create a single-page web application with an out-of-the-box solution. Learn by doing. Try to make an example app. Don't go and try to create the most complex app you've ever heard of. I would say start simple. Make sure you're using best practices. Continuously reference documentation to see if you're using hooks the way you're supposed to and that sort of thing. And it should come pretty easily. I think one of the great benefits of React is how easy it is to pick up and learn. There are a lot of different pieces of React and a lot of different concepts to learn, but it's really well worth it in the end because you're going to encounter React in your day-to-day work, hopefully for the rest of your career. And there's a huge community behind you ready to help and answer questions about React too.
Recall the concept of the single-page application, or SPA for short? This is a one-page website where some of the page's content changes based on user interaction. SPAs differ from traditional websites, where each web page needs to be loaded as the user navigates around the site. This frequent reload can be considered inefficient, as some of the same content such as logos, navigation and footers need to be loaded again. And one of the most popular ways to build an SPA is with the React library from Meta. React is used to run many of the world's most popular websites. Often on these sites, you'll type a search term into the site's input box. The site then returns the relevant content or results. But you might notice that even though the content has updated, the site's URL doesn't change. As SPAs only load the content as required, they can be ideal for businesses and enterprises who need a web app that offers rich user interfaces, speed, scalability, and flexibility. As an aspiring developer, you may feel like there are a lot of new concepts and processes to understand when working with React, but you can be sure that you will have an opportunity to get familiar with and use them. In this video, you will learn about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Let's begin with components, one of the core building blocks of React. When Meta released the React library, it included the concept of something called component-based architecture. This is essentially a design philosophy for building software based on reusable components of code. Each component consists of well-defined functionality that can be inserted into an application without requiring modification of other components. Because components are reusable, they can be used multiple times and easily inserted anywhere where needed. This results in components that can exist within the same space, yet interact independently from each other. One of the advantages of developing using components is that many developers can work on the same project without interfering with the code of other developers' components. As you may recall, modern front-end web development revolves around the concept of creating standalone parts of the user interface, or UI for short. Well, in React, these standalone parts are created using components, which form the foundation of all UI design. It's important to know that all UI is composed of simple components that can be combined into more complex components. In fact, you can think of an entire website as just a collection of components. For example, consider the product checkout page of an e-commerce web application. The page consists of three sections: a header, a payment section, and a sidebar. The header section contains the company logo with a navigation menu and a button to view the shopping cart. The payment section area contains a form where the user inputs their payment information. Finally, there's a sidebar with the order summary information. As the components are self-contained, they have their own HTML, CSS, and JavaScript logic for functionality. For example, the payment section component has a JavaScript function that submits a payment when a button is clicked. It's important to know that the use of components in website UI design is not limited to just React. Many websites' front-end or UI are built on the foundations of components and composability. But React is a powerful tool for streamlining the process of building components and composing them. It performs these actions efficiently as components are rendered to the DOM without significantly impacting the browser's resources. This is called component rendering, and you'll learn more about this and its associated render method later. You may recall that the DOM is a logical tree-like structure representing the HTML document, and it uses nodes to describe the various parts of the document. Before React, you could still build component-style layouts. However, it involved much more complicated DOM manipulation and code, making the layouts more complex and harder to work with. This resulted in something known as spaghetti code, a term developers use in web development to describe code that is complex, convoluted, and difficult to understand, like spaghetti. React prevents this spaghetti code by avoiding any manipulation of the DOM. Instead, React provides something known as the virtual DOM. You may recall that this is an in-memory representation or clone of the real DOM, which minimizes updates to the DOM itself. React uses the virtual DOM to update the browser DOM only when needed. This ensures that the update is as minimal as possible, increasing the application's speed and performance. In this video, you learned about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Recall how you learned about functions in JavaScript? They are reusable blocks of code that can take an input, perform some procedure or calculation, and then return an output. Well, a React component acts much like a traditional JavaScript function. In this video, you'll continue your exploration of the structure of the React architecture by learning about functional components, component types, JSX, and transpiling. React provides two types of components: functional components and class components. They behave very similar in React to traditional functions and classes in JavaScript. Don't worry about class components for now, you'll learn more about them later. Instead, let's just focus on functional components which act like a JavaScript function. In the default React application, only one component is rendered, and it's the app component located inside the index.js file that's located inside the source folder. It's important to know that every React app must contain at least one component, and it's called the root component. This component is loaded using the import statement. You'll learn more about the import statement in React later. For now, just know that it's used to import code needed for React to work, such as the import React and import React DOM statements. The syntax to render a component is very similar to a self-closing tag in HTML. You just place the component name inside the left and right angle brackets, and don't forget the /. The root component can contain other components that developers create to represent the various UI parts of the application, like in the e-commerce example that you learned about earlier. And recall that this component is ultimately converted to a DOM fragment and placed into the existing DOM as a child of the HTML div element with an ID of root. This div element is then rendered to the browser. If you analyze the app component, you'll notice that it looks very similar to a JavaScript function with some HTML code inside. You may also notice an export default statement. You'll learn more about this soon. For now, just know that you need it to make your components available. Okay, so now that you're familiar with the concept of functional components, let's explore how web developers create them in React. React is scripted using a special kind of syntax called JavaScript XML, or JSX. For many React developers, this is known as a syntax extension to JavaScript. So, what is JSX syntax like? Let's find out by going back to our React default app component. Recall that in the return statement of the app function, it seemed that some HTML content is returned. Well, this content is not exactly HTML, it's JSX. JSX syntax looks very similar to HTML, and one of its advantages is that it allows you to write JavaScript code inside what looks like HTML elements. In fact, you can think of JSX as a combination of custom HTML and JavaScript. This allows you to make your website dynamic. You'll learn more about the differences between HTML and JSX later. For now, just know that you can place this syntax inside the return statement of a functional component. It's also important to know that a React component won't render until it's used as a JSX element, just like a JavaScript function declaration won't run until it's called or invoked. Okay, so now you know what JSX is. Let's explore the steps involved to create a React component, which will contain some JSX code inside a heading 1 HTML element to display some text on a web page. First, you create the component, which is basically just a JavaScript file. Since its purpose is to return some heading text, you name the file heading.js. Notice that the first letter of the component name is capitalized. This is because there's a difference in how React treats capitalized and non-capitalized component names. So it's important to remember that all component names in React must be capitalized. Why is this? Well, because React treats lowercase components as regular HTML elements. Capitalizing a component name helps React to distinguish JSX elements from HTML elements. Now let's continue with our component. Next, inside the app.js file, create a function named heading. The function name must also be declared using a capital letter for the first letter of the function. Then, inside the function body, you create a variable named title and assign it the string value of "this is some heading text." Now you're ready to create the return statement of the function. Inside the parentheses of the return, insert a heading1 tag and inside it, place the variable named title. To make React evaluate the title variable, you need to place it inside curly brackets. If you didn't use curly brackets, you'd get the word title instead of "this is some heading text." At this point, it's worth remembering that while you are creating HTML-like syntax, you are actually coding inside a JavaScript file. And because of this, you can output a variable inside your JSX code, something you cannot do when writing static HTML. The overall syntax instructs React to render the heading HTML element with whatever text value that is stored within the variable named title. This rendering happens behind the scenes because of something called transpiling. You can think of transpiling as a process of converting JSX to HTML, and you'll learn more about this later. In this video, you learned about functional components and how to create them in React. You also learned about JSX, which acts like a combination of HTML, CSS, and JavaScript that you can use to generate dynamic content inside your functional components. Finally, you explored the concepts of rendering and transpiling. If you would like to learn about these concepts in more detail, there's a link to an additional reading at the end of this lesson.
In this video, you will further explore the concepts of components in React and learn how to create a component from scratch. You'll be introduced to the concept of the export statement and how components can be used to create reusable blocks of code. I've launched VS Code here and I have the creating component folder open in the built-in terminal. Now I'll execute the command npm init react app dot. The dot character instructs VS Code to run this command in the current folder. In other words, I'm using create react app to build a new app for me inside this folder. I execute this command by pressing the enter key. I wait for the app to build, and once it's ready, I can start the app by typing npm, then a space, followed by start. The process of building the React app could take a couple minutes, so just sit tight while it builds. Great, my React app has started and loaded in the browser at localhost 3000, which is the local server. Notice that I have all these files and folders in the left pane of VS Code now, such as node modules, public, src, and files like package.json. You'll learn more about these later. For now, the only folder I need to work in is the src folder, so don't worry about all these other files and folders. Instead, I want you to focus on how to build a component in React, and to do that, let's have a clean start. The easiest way to do this is to remove all the code inside the function inside the app.js file. I guess you might say this is the simplest possible component. I'm declaring an app function and I'm exporting it as a default module. I save my file and notice that my app is just a blank page. Now let me create another component that'll contain some text that I want to display in the browser. To do this, I create another function called header, and in the function body, I'll just return some greeting text inside an h1 JSX element. Inside the h1, I type hello world. My code looks good now, but my screen is still white. This is because I'm not yet rendering anything from my app function. To do this, I need to return to my app function and call the header function from it. I use the JSX element syntax to render a component, which is the name of my function. So inside the body of the app function, I create the return statement and type the function name of header inside left and right angle brackets, not forgetting to add the / before the right angle bracket. Notice that the syntax to render a component is very similar to a self-closing tag in HTML. Press Ctrl S or Command S if you're on Mac to save everything again. Great, my code is working now, and I notice an HTML heading with the text "Hello World" displayed in the browser. Congratulations! In this video, you learned how to create a functional component. This component named app calls another component named header, which displays an HTML heading with some text. At the moment, the header component code exists in the same file as the app component. To make the header component isolated and reusable, I need to place it in its own file. Then I can reuse it multiple times in the application anytime I want to display a heading element with some text. And you'll learn how to do this very soon. In this video, you learn how to create a functional component in React and render it to the root component named app.js.
As you might already be aware, it's important to organize or structure your React components so that they're easy to access. But what does a structure look like? What files and folders are found within a typical React application? The React project structure is the focus of this video. By the time you reach the end of this video, you'll have learned how to explain the default folder structure of a React project, outline the benefits of the folder structure, customize the folder structure to hold components and assets, and explain the benefits of planning folder use for app development. Let's begin by examining how the default files and folders are laid out in a React app project. When you build a React app using the command npm init react app, your project is comprised of a specific file and folder structure. Notice that there are 3 folders named Node Modules, Public, and SRC or Source. Let's explore each of these folders briefly now. First, let's begin with the Node Modules folder. You can think of this folder as a repository for all the modules in your React app. The Node Modules folder is automatically added when you install a specific npm package. You might recall that packages are groupings of files and/or node.js modules. Developers use packages when they want to add a piece of functionality that someone else coded and made available to other developers via the npm ecosystem. Don't worry too much about the Node Modules folder. For now, just be aware of it and that it's needed for your React app to work. Next is the Public folder, and it contains the assets that will be displayed to the user in your app. For example, image files for logos, the favicon which displays an icon in the Browser tab, and the robots.txt file which is used for search engine optimization. Also, there is a manifest.json file which is used to provide some metadata to a device when your React-powered web app is installed on it. While all these files are necessary, the most important one to know about for now is index.html. A React app gets injected into the specific element inside the body of the index.html file. Based on changes happening inside a React app, it injects those updates in that same div of index.html. You'll find out more about how this works later on in the course. Finally, let's explore the contents of the SRC or source folder. This folder contains all the essential component files required to ensure that a React app functions. And notice that there are some files already in this folder. These were automatically created when I used the npm command create react app to build a starter React app. As a React developer, you'll probably spend most of your time within this folder, so let's get a little more familiar with some of these files now. You may be familiar with some of them already, such as index.js and app.js, which are used to render the root component of the app. Let's briefly explore the others. App.css contains the styles for the app.js component, and the index.css file contains the styles that are used in the entire app. App.test.js, setuptests.js, and the report web vitals.js are files related to the app's performance and testing. The logo.svg file is displayed on the start page of the default app when the app is displayed in the browser on the local host. While these can be useful and their functionality is important, I can still safely delete them without affecting React's ability to create a very basic application. I just need to also remove the code that references them. This is because React doesn't have opinions on how you organize your files and folders in the source folder. However, there are a few common approaches popular in the ecosystem, and you'll learn about them soon. It's at this point it's also worth remembering that the most important file in the entire source folder is the index.js file. This file imports everything that this React app needs to render a working React app. Okay, so now you have explored the main folders. Let's explore the files in the root of the default app. Root files are additional files that are found in the root of the project folder itself and include a gitignore file, 2 JSON files, and a README file. The .gitignore file is used in version control, and it's used to specify what files and folders must be excluded from a project. It's important to know that this file is not specific to React. This means that other systems use this file too. The readme.md file is a markdown file that gives some basic information on this project. Developers use this when they want to share the project's code on a site like GitHub. The package.json file lists information pertaining to my app, which allows npm to run several scripts and perform various tasks in the app itself. Finally, the package.lock.json file holds the list of all dependencies with their specific versions. The package.json file helps npm rebuild the app on another machine, or if we delete the node modules folder with all the files that our project needs to run, the package.lock.json file has all the information for npm to be able to rebuild those files reliably. This file is there to ensure that npm tracks all the modules installations properly. As a general rule, it's better to leave these files where they are for the moment, as they are required for the app to function. You should now be able to explain the default folder structure of a React project and outline the benefits of the folder structure. In addition, you should know how to customize the folder structure to hold components and assets, and be able to explain the benefits of planning folder use for app development. Good job. One of the advantages of component-based architecture is that your app is split up into individual self-contained components. And as you have already learned, these components can be used to build powerful UIs based on reusable components of code. In order to create a fully functioning React app, you need to create a collection of components. But with the app broken into several different components, you might be wondering, how do you locate and integrate them all into your app? In this video, you'll learn about the concept of modules and how to manage your React components by placing them in a components folder. Finally, you'll explore the structure of the import and export statement. As a developer, you often need a way to use and reuse components that may have been defined elsewhere or created by someone else. For example, do you recall the concept of modules in JavaScript? Modules are standalone units of code that you can reuse again and again. Being standalone means that you can add them to your programs, remove them, and replace them with other modules, and everything will still work. Well, in React, you can make use of this JavaScript feature to separate your components by placing them in their own file. Then you can use the import and export statements to make the files communicate with each other. The export statement is used to make a module available to another module. It helps to think of every JavaScript file as a module. Then in order to make the functions and variables available to other files, you need to export them, which makes them available via the import statement. In JavaScript, there are two types of exports: default exports and named exports. The default export is used when the function name is the same as the file name, and named exports are used when you want the function name to be different from the file name. At this point, you may be wondering, what is the difference between modules and components, since they are both essentially just JavaScript files? And you're right. While they have similarities, it can help to think of a component as a single part or small piece of functionality, like a button. Then you can think of a module as something that's larger than just one component, like a series of components. This technique of splitting your code into several modules is known as modular programming, and it complements the component-based architecture of React. To help you understand this better, let's explore the following scenario. Suppose you're a developer currently in the process of building an application with React, and there are several components that need to be included in the app. Some of the required components have already been created by your fellow developers, so you need a way to import them into your app. To do this, you need to use the operation known as importing. And in React, you import components into your application using the import statement. You may have already noticed the import statement in the default index.js file, where the app component is rendered. In React, to import a component, you use the keyword import, followed by the component name you want to import. Then you use the keyword from to specify the location of where the component is located. You need to use a file name sequence such as a dot, / before the file name, but the file name extension is not required. Okay, so now you know about the syntax of the import and export statement. Let's explore how you can structure your component in React. Remember that a component is essentially just a JavaScript file. React doesn't have strict rules on how you put files into folders. However, there are a few common approaches you may want to consider. One approach is to place all components in a folder named components. This allows you to structure your projects by grouping similar files together. For example, suppose you are building a payment page for an e-commerce app. The page contains 3 sections that will each be represented by a component in React. First, a header section using a component called header, then a payment section using a component called main, and finally a sidebar using a component called sidebar. Each component will be called and have its contents returned to the root component of our application, which is app.js. In this video, you explored the concept of modules and the structure of the import and export statement. You also learned how to manage your React components by placing them in a components folder. By now, you should be familiar with the concept of functional components in React. They are reusable blocks of code that act much like a JavaScript function. Recall that in JavaScript, you can make your functions more flexible by declaring them with parameters that allow you to pass in values as arguments when you call the function. Well, in React, you can perform a similar action using something called properties, which are represented as props. In this video, you'll learn about the props object and how developers use it to pass data from one component to another. Then, you'll explore component hierarchy and learn why components are said to have a parent-child structure. Before you begin your journey with props, let's revisit another piece of JavaScript functionality that will help you understand how props work. It's called the JavaScript object. Recall that in JavaScript, an object is a special type of variable that can contain many values. You use objects when you need to store groups of related data of different types, and each data type is known as an object property. For example, suppose you create an object called fruit that contains properties for type, quantity, and color. Remember that these properties consist of name-value pairs, and you can access the object's properties using dot notation. In React, you can use a similar technique to pass data from one component to another using the properties object, or simply props. Props allow you to pass data from one component to another. It's helpful to think of props as arguments that components can accept and are passed using JSX syntax, much like HTML attributes. Inside a function, you use the keyword props. Okay, now that you're familiar with the concept of props, let's explore an example to send some props to a component and print them out in a React app. Suppose you have the default code for the React app open. In the index.js file, you call the app component. Inside the app component, you return an h1 heading with some static title text. While this code works, you can make this heading dynamic by using props. Let's now explore the syntax involved to create this. In the root component index.js, you send the value you want to pass to the app component as an argument in the form of an HTML attribute. Next, in the app component, you accept this argument using the props object. To do this, you add the keyword props to the function declaration inside of the parentheses. Finally, to access this object's properties, you use dot notation to reference the name of the object's property that was passed as an argument by the HTML attribute. Once again, remember to enclose your code inside curly brackets so React knows that you want to work with a props object and not static text. Because props is essentially a JavaScript object, It can accept many data types ranging from simple types such as strings and integers to more complex types such as functions, arrays, and objects. As a result, props allow developers to have greater flexibility when creating and working with components, especially when you want the flow of data in your app to be dynamic. While you just explored a basic example to dynamically print a heading, you'll get a chance to practice with more complex data structures using props later. Okay, so now you're familiar with how props work by sending data between components. Let's explore this data flow in a little more detail. When two components communicate with each other, the component sending the props data is known as the parent, and the component receiving the props data is known as the child. And as you've just learned with the example earlier, this parent-child relationship allows parent components to pass data down to child components using props. It's also possible for parent components to send the same data to multiple child components. However, it's important to know that this communication is a one-directional data flow. It's not possible to communicate from the child component back to the parent component using props. Instead, developers use other approaches. Don't worry about that for now. You'll learn more about them later. Although props are a very powerful tool in React, they do have some limitations. For example, you just learned about how it's not possible to send data from the child component back to the parent component using props. Another important limitation has to do with something called pure functions. In programming, a pure function is a function that will always return the same output for the same argument values that are passed in. Don't worry too much about pure functions for now. Just keep in mind that in React, when you declare a component using props, it must never modify its own props. In this video, you learned about how props are used to pass data to components. You discovered that a prop is a special React object that works in a similar way to a JavaScript object, and that its properties can be accessed by dot notation. You also learned why developers use props in order to make their apps more dynamic and flexible. Finally, you examined some of the limitations about using props in that you cannot use them to send data back to a parent component, and that functions using props must never modify its own props. By now, you should be familiar with the concept of props, and that they allow you to pass data from one component to another. Developers use props when they want the flow of data in the app to be dynamic. This makes the app more versatile, helping it consume data easier. In this video, you'll learn the syntax involved to use props in components. You'll also explore the passing of props to and within a component using functions. During this course, you were introduced to an example of how to build a simple blog layout in React using components. Now you'll be introduced to a new component called the nav component. Developers commonly build navigation menus using HTML unordered lists. A navigation menu is basically just a list which can be styled easily with CSS. Such a snippet of code is well suited to be placed in its own React component, making use of the HTML nav element to act as the block of code to return the JSX from inside the function. For example, the return statement can contain several HTML-like elements such as UL and LI tags. And this same nav component can also be rendered as a JSX element to which we can pass dynamic value with props. In order to do this successfully, you need to be comfortable with the concept of attributes. The best way to develop an understanding of attributes is with a live example of building a component using props. Here's a practical way to work with props. I'm in my app with the header, main, and sidebar components, and all of them are rendered from the app component. The app component is in this case referred to as the parent component, and the header, main, and sidebar components are referred to as the children of the app component. I'll now pass data from the app component to each of its children components. First, the header component receives a name prop with a value of Anna, and a color prop with a value of purple. I'm sending those props from the header JSX element inside the app component's return statement. Press Ctrl+S or Command+S on a Mac to save these changes. However, My recompiled app is not showing any changes because I send this data through the props object to the header component. I'm not using this data in the header component. So let me open the header component and I'll first pass in the props object. For now, I'll just console log the props object. Again, press Ctrl S or Command S to save the update and wait for it to compile. If I now inspect this object in the console, I find the console logged props object and it comes with two properties, the name Anna and the color purple. I can now access the values of the two properties inside the header component using props.name and props.color. To make sure that the expressions are evaluated inside the JSX syntax, I must surround them with an opening and a closing curly brace. I press Ctrl S or Command S on the Mac again and wait for it to compile. Now my header shows the props data it received from the parent component. I'll now update the main and sidebar too. Back in the app component's render statement, I add the greet prop with the value of howdy in the main JSX element and the value of hi in the sidebar JSX element. I open the main component file and receive the props object, then output the value of opening curly brace, props.greet closing curly brace. I can now delete the hello string. Similarly, in the sidebar components file, I'll also receive the props object and replace the hello with an opening curly brace, props.greet closing curly brace. I click File, Save All and wait for the app to compile. All my components are now using the data they received from their parent component, using their respective props objects. You should now be able to effectively demonstrate the passing of props to and within a component using classes and functions. Great work! At this point in the course, you've been introduced to the concept of JSX and how it's used to interact with components. In this video, you'll explore JSX in more detail in the context of component and styling. You'll also learn how to mix JavaScript, HTML, and CSS within a component. So, what is it that makes JSX so special? In one word, expressiveness. Developers can express what they want React to render using a very expressive syntax, almost identical to HTML or XML. In other words, JSX allows developers to write HTML directly inside JavaScript code. For example, you can add a navigation function to a website by creating a nav component, then place the HTML semantic nav element and an unordered list inside. And because this is React, the list values can be made dynamic by passing values as props. It's important to know that a regular JavaScript function is used to define how React should render the component, wherever it's referenced using the nav JSX element. And this is what makes JSX so powerful, like the fact that you can insert specific JSX expressions such as variables and props. The reason why this is so great to work with is because anything that's placed inside the curly braces of your code is essentially regular JavaScript code. For example, you could calculate a series of simple expressions using the li or list item tag. This means that you can think of the curly braces as being special areas where you can write any kind of JavaScript code you like. And you can write the rest of the code inside the return statement. Okay, so now that you've learned a little more about JSX expressions, let's focus on some JSX rules inside the return statement of the function. The return statement can be thought of as the area of expressive syntax that allows you to write regular HTML code as you'd like to have it in your rendered app. But if you need to return HTML code over multiple lines, it must be placed inside parentheses. This allows developers to alternate between regular HTML tags and dynamic values represented as JSX expressions inside curly braces. It's also important to remember that the HTML code must be wrapped in a top-level element, such as a div tag. If you do not want to add extra div elements to the DOM, you can use something called a fragment instead. This is like an HTML open and close tag without the tag name. While you can think of the code inside the return statement as regular HTML, it's worth remembering you are in a JavaScript file, and as a result, there are some differences. For example, you cannot use the keyword class to work with CSS classes in your HTML elements. This is because class is a reserved keyword in JavaScript. You must use a slightly different keyword called class name instead. Also notice that class name is written in camel case, which depicts the separation of words by using a single capitalized letter. You can use class name to list any number of CSS classes to style a specific JSX element inside a component. This is just like how you use the class attributes in regular HTML, and it's only one of the many ways you can style React apps. You'll learn more about how to do this later. For now, just know that this is the closest to what you would do, like if you were working with HTML and CSS website layouts. There are some other differences, and you'll learn about them later, but in practical terms, you can consider the code to be pretty much just like regular HTML. In this lesson, you explored further the concept of JSX styling and how it's used in React. You have now furthered your understanding of how to use JSX to mix JavaScript, HTML, and CSS within a component. Great work!
Recall that there are 3 techniques to include CSS in HTML documents. The first is inline by utilizing the style attribute inside the HTML element. Next is internal by using the style element in the head section. And finally, external by linking to an external CSS file using the link element. In this video, you'll learn how to take CSS style rules from an external file named index.css and add it inside a component as an internal style. These style rules can then be referenced by your code inside the return statement of the component. Notice that the components are styled by the external style sheet index.css. For this video, I'll continue working on an app which consists of the components header, main, and sidebar. This time, the focus will be on using internal styling inside the sidebar component. To demonstrate this, I don't need to move all the code from the index.css file. Instead, I'll just focus on the styles related to the sidebar component. For example, I select the CSS code for aside and cut it by pressing Ctrl X or Command X on Mac. After saving, notice that this removes the styling from the sidebar component displayed in the browser. Now let's go to the sidebar.js file where I'll paste the code before the return statement. This will not affect my component because I'm pasting CSS code into a JavaScript file, so I need to make some changes to turn the CSS rule into a JavaScript object. To do this, I need to declare aside style as a cons variable and then replace the semicolons in the code with commas. I also need to replace the hyphenated names with camel case. It's important to know that because CSS declarations like background are now an object property, I need to make their respective values a string by wrapping them inside double quotes. And I also need to repeat this for the other new style elements as well. Finally, inside the aside tag in the return statement of the component, I need to add a style attribute by typing style equals aside style as a JSX expression. I then choose Save All in the File menu to save my changes. Notice that the sidebar component appears in the browser as before I edited the index.css file. So that's an example of using inline CSS styling directly inside a component. In this video, you learned how to take CSS style rules from an external file named index.css and add it inside a component as an internal style.
Recall that JSX is a syntax extension to JavaScript that is used with React. It allows developers to write HTML as part of their component code, and is frequently used in React as it offers greater flexibility. In this video, you'll learn how JSX is used and how to use its key feature, embedded expressions. First, let's examine a JSX example that will output some text on a web page. The code consists of a paragraph HTML element containing the phrase "Hello World." It is assigned to the constant variable named result. Note that when this JSX code executes, the result variable will contain a React element that can then be inserted into the web page. This is one of the key features of JSX, building React elements from HTML code automatically. Let's explore another important feature of JSX, which is embedded expressions. Embedded expressions allow developers to insert the values of JavaScript variables into the HTML of the resulting React element. Embedded expressions can also embed the output of functions. Let's say you need to output the person's name in a specific format. To do this, you can first create a function named formatName that will return the first name and surname with a space character between them. In your JSX, you can then call this function inside the curly brackets. As with the previous example, the value that the function generates for the JavaScript variable will be output in HTML. Expressions can also be used for HTML attributes. This is useful if you need to insert the address of a person's profile picture. To do this, first you would store the profile picture address in a variable named URL. The image will be displayed using the img element, so you should embed the URL variable into the src attribute. Note that the double quotes are not needed for the attribute value, as JSX will automatically add these. This is just one example of how JSX is an efficient way of outputting HTML elements that contain JavaScript variable content, and you'll encounter more as you progress. In this video, you explored several JSX examples, including one that uses embedded expressions to insert the values of JavaScript variables into HTML within a React element.
I'm building an application using React, and I now need to add a new feature to the app that renders images. I can do this by embedding a JS expression in an attribute, specifically the src attribute of the HTML image tag. Over the next few minutes, I'll guide you through the process as I complete the steps, and by the end of this video, you'll be able to demonstrate how to embed a JS expression in an attribute, including adding additional styling and importing additional assets, and utilize additional assets within an app by importing components. Now I'm in the app.js file of a new project and start with an app component that returns the h1 header text hello world. I've previously copied the avatar profile image from the Coursera GitHub account, which is publicly available through the GitHub API. I've pasted the images into the root of the src folder and named it avatar.png. In order to use the image, I need to import it into the app component. I then add a new function in the app.js file named logo. The logo function is essentially a separate component, but to keep things clean for this example, I'll save the code in the app component instead of a separate file. The logo function accepts the props object, and inside of the logo function, I declare a user pic const and assign it a JSX element. This is an image element, and I'm passing the imported avatar PNG image as the value of the src attribute inside this image element. Finally, I'm returning the user pic const from the logo function. Back inside the app component, I'll now render the logo component by adding the logo element inside the app component's return statement. Let me now preview my app in the browser. Great, so it displays the header text along with the image. Keep in mind that if I were to continue building this app with more components, it would be best to extract the logo component to its own file and then import and render it as needed. And that's a demonstration on how you can embed a JSX expression in an attribute, in this case, the src attribute of an HTML image tag.
Well done! You've reached the end of this module on React components. Module 1 gave you an overview of the basic structure and use of React.js. The purpose was to enable you to produce single-page applications with React. Let's take a tour of the lessons to determine how it did just that. First, you learned about how React is used in the real world from Meta software engineer Katie. Then, to lay the foundation for the hand-on labs, you had a quick summary of the fundamentals of HTML, CSS, and JavaScript. And then you learned how to set up a project in VS Code and how to work with JavaScript modules. The second lesson was all about React components and where they're stored within your applications. In this lesson, you were introduced to component-based architecture, a design philosophy for building software based on reusable components of code, like the React library. You learned about component types and component style layouts that use the virtual DOM. And you learned how to create components that form the foundation of UI design. In this lesson, you also learned more about JSX, a special kind of syntax that acts like an extension of JavaScript. You learned how to transpile it, in other words, convert JSX to HTML, which helped you to understand how a component is built. And in the ungraded labs, you learned how to build a new component inside the app component and have it rendered on screen, as well as how to save a component to its own file and importing it into its parent component so that it can be rendered on screen. The third lesson was about component use and styling. You learned how to pass data from one component to another using properties, and your ability to do so was tested in the ungraded lab. And in the other ungraded lab, you learned how to render one component multiple times using different props. You also learned more about how to use JSX and its embedded expressions, and how to style JSX elements in a way that is functional and looks good. As part of this lesson, you learned how to use and manipulate props and components, define components using function expressions and arrow functions, invoke functions inside of JSX expressions, use expressions as props, declare components that require props, and use expressions and embedded expressions in attributes. After completing this module, you are now able to explain the concepts behind React and component architecture, create a component to serve a specific purpose, create a component folder and demonstrate how to create and import files within that folder, use and manipulate props and components to affect visual results, and describe how to use assets within an app to apply styling and functional components. That's a great start to your React journey. Well done on completing this module, and get ready for the next one. By now, you're probably familiar with events in JavaScript. Recall that events are the process by which JavaScript interacts with HTML and can occur when the user or the browser manipulates a page. They provide enhanced interactive experiences, such as responding to mouse clicks, movements, or keyboard commands. Because events usually rely on some sort of interaction, they need to wait and listen in the background for that interaction to occur before they can be triggered. Every HTML element contains a set of events that developers can access by using HTML attributes commonly referred to as event listeners. For example, it's a common feature of a website or app to have a button that, when clicked, causes something to happen. This action is an example of an event, and is accomplished with either event listener methods or by defining specific JavaScript functions. Developers can use events to execute JavaScript code in response to an action based on user interactivity, like clicking a button. This process by which the HTML button communicates to the JavaScript event handler to execute some code in response to the event action is known as triggering. For example, you might want to listen for a click event on an Add to Cart button. Once you capture such an event, you might want to run some JavaScript code. In this example, add a circle with a number 1 in the shopping cart to indicate one item has been added. If the same event gets triggered or fired again, our event handling code then handles the event by updating the count in the circle next to the shopping cart icon. The circle then displays the number 2 to indicate that there are 2 items in the cart. Events are a powerful tool and make up part of the document object model. As an aspiring React developer, you'll need to know how to work with events as they are handled a bit differently. By the end of this video, you'll be able to identify the broad types of events available in React and describe some of the most commonly used ones. You'll also know how to explain the event handling process in React at a high level. In React code, events are handled using JSX event attributes, which are very similar to HTML event attributes that you may be familiar with. For example, the click handling attribute in HTML is the onClick attribute with all the letters lowercased. The equivalent click handling attribute in React's JSX is the camel-cased onClick attribute. Remember that camel case means that the first letter is lowercase and the separation of words is indicated with a capital letter rather than a space. There are many events supported in React which can be divided into several groups. Those groups include clipboard events, composition events, keyboard events, and many more. Each group usually holds multiple events. For example, supported mouse events include onClick, onContextMenu, onDoubleClick, and several others. You'll also find that the clipboard group has the useful events onCopy, onCut, and onPaste. There are far too many events to cover here, but you can find a complete list in the additional reading. The large number of event types that are accessible in React may seem overwhelming at first, but note that it's actually the browser that comes with these features, as the various devices that we use to access the internet have given rise to many ways for users to interact with websites. This means these events are not specific to React, and it's probably not necessary to learn about all of these events. Also keep in mind that many of these events are related to specific use cases. For example, several of the mouse events are limited to the drag and drop API. In other words, at this point in your learning journey, your focus should be on understanding the overall event handling process and what capabilities events can open up to you. In this video, you learned about the types of events available in React and how they came to be. Next, you'll explore specific examples and build the skills to use events confidently for various situations.
I will now show you how to handle several events in React using components. As a start, I've added a new component to the src folder. I named it btn, and for now it's just an empty function with a default export. Let me simplify the app.js file's return statement. First, I'll delete the logo import statement and import the btn component instead, and then remove the contents of the return statement. Then finally, I'll add the btn.jsx element so that it can get rendered. Back in the btn component, I add a button in the return statement. The button reads, "Click me." Press Ctrl S or Command S on a Mac to save, and the button renders on the screen. Now I'd like to handle a click on this button, so I add the onClick synthetic event, then an equal sign, an opening curly brace, click handler with a capital H, and a closing curly brace. In the return statement, I distribute the code on several lines to increase readability. Now I'm setting up the click handling behavior. Whenever a user clicks on the button, that'll evaluate an expression named click handler. I now need to define this click handler, and I'll set it as a function expression, meaning I will use the const variable keyword and name it click handler. Then I'll assign an arrow function to it. That's it. I've just set up a click handler that receives the click event that's fired from this button and handles it by outputting the word clicked in the console. Again, I save my changes, and in the browser, I open the developer tools. Now I locate and activate the console tab in the developer tools. I'll also zoom in on the button. When I click the button, the word clicked appears in the console for every click event. Back inside the btn.js file in VS Code, I select all the code in the btn component, right-click on the selection, and click the copy command in the contextual menu that pops up. Next, I use the keyboard shortcut of holding down the Control key, and while it's pressed down, press and release the K button, then pressing and releasing the C button, and finally releasing the Control key. So, Control K C. That comments out all the highlighted code. Right under this commented code, I now press the Control V keyboard shortcut to paste in the code that I have previously copied. I will now show you how to handle a different event. Let me replace the onClick.jsx event handling attribute with another one, and thus handle a different event. For example, I can replace the onClick attribute with the onMouseOver attribute, and update my event handling function accordingly to read mouseover. I save my changes and wait for the app to recompile. This time, when I hover over the button, the words mouseover are showing in the console. In this video, you've learned how to work with event handling JSX attributes in React.
Every time you click or tap a button, scroll down a page, or cancel a boring notification, you're producing events in the browser. And as you learned earlier, in order for these events to have any effect, you need to use event handlers that will then execute an action. For example, suppose you use a button to open a menu. Clicking the button is the event. the event handler is onClick, and the action that follows the event is opening the menu. There are a few approaches to adding event handlers to your React code that have different advantages, so you'll become familiar with each of them. By the end of this video, you will be able to describe the syntax differences for using event handlers in HTML and React. You will also know how to explain HTML function call and React component inclusion, and discuss the advantage of the component level of control. Suppose you're a developer working on a React app and you need to create a button that will trigger an event when a user clicks on it. With that scenario in mind, let's examine some code that accomplishes this in plain HTML. You might open a tag called button with the ID JSBTN. You then assign the onClick event handling attribute and set it equal to the click handler function. Next, you can add clickMe as the button text and finish with a closing tag. The code has an ID HTML attribute with the value JSButton, along with the event handling attribute onClick. While the HTML code in the example seems pretty straightforward, it's recommended to use JavaScript for scenarios like these instead. Why is that? Well, you'll find out later. But for now, you should understand that the equivalent code in JavaScript consists of two primary steps. First, you should use JavaScript to plug into the specific HTML element on which you'd like to listen to for an event. In the previous example, the HTML element is JSButton, which signals that it's a target element for allowing JavaScript to take control of the HTML structure. Second, once you've gotten access to an HTML element with JavaScript, you can then use the built-in addEventListener method on the document object to attach a specific event listener. When you apply this method to the previous example, HTML is removed from the equation, but the code, on the other hand, is a bit more complicated. Specifically, you need to first declare a constant called JSButton and assign the value from the DOM. Then you need to add the clickListener event and the function to run the code. Going back to React, the biggest difference in syntax involves the use of the addEventListener method. In React, the rule is to avoid manipulating the DOM directly as much as possible. You should set everything up declaratively, meaning that you describe updates to React and let it figure out the rest. This is best done using event attributes, and fortunately, one-to-one mapping between HTML event attributes and JSX event attributes means it's easier to learn. Event handling in React is overall quite similar to HTML, but note that there is no function invocation syntax in event handling attributes in React. In other words, while in plain JavaScript you would need to pass an invocation to an event handling function as a value to the onClick events, in React you should not invoke a function. Instead, you just pass a reference to the event handling function without invoking it. To illustrate that point, let's compare the syntax of an HTML click handler event and its React JSX equivalent. In HTML, you provide the event handling attribute starting with on, and you append the name of the event, all lowercase. After the equal sign, you use a pair of double quotes, and inside of the double quote delimiters, you invoke the function that will run. Contrary to HTML, in React, you provide the event handling attribute starting with on, and you append the name of the event with each word's first letter capitalized. After the equal sign, you use the JSX expression delimiters, that is, the opening and closing curly braces, and inside of the curly brace delimiters, you add the name of the function to be run. Make sure not to invoke it. Finally, one more feature only used in React is the passing of function declarations as props. For example, in an app component, let's say you'd like to render a child component named counter. You can pass some data from the app component to the counter component using a prop. In this case, let's use an onClick prop that passes in the data that you want the counter component to receive. And there you have it. So the next time you're clicking buttons on a web page, closing notifications, or simply browsing through, you'll understand that those events are supported by some form of event handling. In this video, you learned how to distinguish the syntax for event handling in HTML and JavaScript. In this video, I'm going to demonstrate how to toggle the value of a Boolean state variable using user-triggered events, and how to handle multiple events on a single JSX element. In the example that you'll explore next, the code consists of another example of a component than what you've been used to so far in the course. The aim is to demonstrate how all the event handling concepts work together with state, styling, and the use of ternary expressions. Let's say that you have a component that uses state to keep a Boolean value of dark mode on. Based on whether the value of this variable is true or false, your component will render an h1 heading with some text in it, either as a dark theme or as a light theme. Additionally, it's possible to switch the theme with a button click. Now let's continue with an in-depth demonstration of event handling. I'm going to demonstrate event handling with an example so that you can gain practical insight into the use of events to provide additional functionality to an app. I'm going to build a component and I'll name it Mode Toggler. So in the Explorer sidebar in VS Code, I right-click the source folder and click the New File command. I name the file Mode Toggler, and for now, it's an empty function declaration with a default export. I press Ctrl S or Command S on a Mac to save my updates. Back in the app component, I update its return statements to render this new Mode Toggler component. I also need to import it on line 1 of the app component and save the changes to app.js. I now return some JSX code from my Mode Toggler component and add a return statement. In this statement, a JSX expression wraps the ternary which checks if the value of dark mode on is true or false. If it's true, it will return whatever is stored in the dark mode value, and if it's false, it will return whatever is stored in the light mode value. However, I don't have the values I'm evaluating yet, so if I save this code now, it throws an error. Instead, I define these values by declaring 3 variables above the return statement. These are dark mode on, which holds a value of true, dark mode, which holds the text dark mode is on in an h1 header, and light mode, which holds the text light mode is on in an h1 header. I save my changes and I get the sentence dark mode is on in the browser. Let me explain what happened here. The dark mode on variable is set to true. Just to do a quick test, I can change the variable name of dark mode on in the ternary to the value of true. Since this value is true, the value that's stored in dark mode will be rendered. If I change the value of true to false, the value that's stored in light mode will be displayed. I have replaced the test word false with our const dark mode on, and now I'll save it and test it again. Now I get the light mode is on displayed on the screen. I add a button with the on-click events to handle this toggle of the value of the dark mode on variable from true to false. So under this ternary statement, I'll add a button with an on-click event handler. I'll also define the handle click function. I start my function by taking the value of dark mode on and change it to the opposite Boolean value using the exclamation mark. That is, the not operator. I then assign this value as the new value of the dark mode on variable. To explain this a bit more, if the value of dark mode on was, for example, true, then the not dark mode on will be evaluated to not true. This not true will be assigned to the dark mode on variable, thus becoming false. I now add the rest of the code for the handle click function, which is an if statement. The logic states that if the dark mode on is set to true, then console log dark mode is on, otherwise console log light mode is on. I could have perhaps written this code a bit differently, but I wrote it in a way that makes it obvious what is happening here. This is always good practice for a developer of any skill level, so that they and others can easily examine the code at a later stage. I save, and once my app recompiles, if I click the Click Me button, I get the appropriate string output in the console. This brings me to an interesting conclusion. Although the console log is updating, there are no changes to the actual heading 1 on the screen. Of course, I can update it manually by changing false to true, then saving the app and waiting for a re-render to confirm that my changes have indeed happened because the previous heading of light mode is on has now become the heading that reads dark mode is on. but as soon as I click the button, the console log changes. However, the heading in the web app doesn't reflect this change. Why is this the case? To understand this, you'll need to go deeper into data flow in React and observe how it moves between components. Fortunately, you'll be learning that soon. Great job! You should now be able to demonstrate how to toggle the value of a Boolean state variable using user-triggered events, and how to handle multiple events on a single JSX element. Imagine you are working for an online retailer that discounts prices regularly to keep stock moving. Sales are announced at multiple points on the website, but what's the best way to keep this information up to date? For example, updating items individually would be tedious and time-consuming. Fortunately, it's possible to change information at a single point and have everything else update automatically to match. This idea illustrates a parent-child relationship, and in this video, you'll explore this concept as it applies to React. By the end of this video, you'll be able to describe the parent-child unidirectional flow of data, and you'll gain an understanding of the hierarchy of React. Let's start with an example of two components which will be used in the same app. First is the promo component, which will return the content of the promo heading component that you will create later. To build the promo component, you can declare the function promo and then write a return statement inside of curly braces. This statement has a div, inside of which promo heading is called. This is then followed by the line export default promo to make the component accessible. Next, let's write the promo heading component. You can declare function promo heading and in curly braces type return opening parenthesis h1 tag the text 80% off sale, h1 closing tag and closing parenthesis. Once again, don't forget to export the component to make it available. Success! You've now created the component promo, which calls a function from the component promo heading to return the text 80% off sale. In this example, the promo component is known as a parent component, and the component it renders, promo heading, is referred to as the child component. Now let's say that the discount increases to 99% off, and you need to update the code to reflect this. One approach is to update the text inside of the h1 tags in the promo details component. That's a quick fix because there is only one change to deal with. However, let's explore a more complex situation. This time, your manager asks you to call the promo heading component in the sidebar and footer component of the web app, in addition to the promo component. They also want two messages displayed: 99% of all items and everything must go. These new requirements mean that the approach of updating the child component will not work quite as well. Why is that? Well, it means that you now have to update multiple components with the same data. This is not in line with the general programming principle of dry, or don't repeat yourself, which aims to reduce needless code replication. Also, consider the following possibilities. While entering the same text into several components, it's possible you make a typing error. Also, what if your boss decides to change the discount again? It means you'll have to change the text in all the connected components once more. But instead of writing the same code over and over, you can change your approach. You can establish a single source of truth that contains the two strings that store the values for the texts 99% of all items and everything must go. This will be contained within the parent component so that any data needed can be passed on to the child components using props. Now let's use this approach to update the promo component. First, you create a single source of truth, a JavaScript object named data. Data is an object that will contain two properties named heading and call to action, both represented as strings. Next, you update the promo component to pass the heading and the call to action values of the data object to the promo heading component. This is known as passing data from the parent to the child component. Back inside the promo heading component, you update it to accept data from its parent component. To do this, you'll need to first delete the existing h1 in the return statement, and then add a new h1 for props.heading and an h2 for props.callToAction. Now, this component accepts a props object, specifically its two properties, heading and call-to-action. The values of the props object are determined in the parent component when you add the specific JSX elements that should be rendered. This was achieved when you rendered the promo heading inside the promo component. Here, you access the properties on the data object using the regular dot notation syntax of plain JavaScript. Knowing this, you can now code the sidebar component and the footer component in a similar way to the promo heading component. Remember that in React, the props data always flows from the parent to the child component. And using props helps you avoid the need to change the data in several places. Instead, you make the change at the data source, the parent, and the updates will be applied to the child automatically. In this video, you learned how the parent-child relationship can be set up so that data flows from parent to child. By storing data in the parent component, you can dynamically pass it to the child component without the need to update children individually. In this video, you're going to learn about data flow in React.js. In this case, data flow is in one direction only. Immediately, a question springs to mind. Why is one-way flow in React important? Let me tell you. This type of data flow ensures that the data is moving from top to bottom through the component hierarchy. It also ensures that changes are transmitted through the system. You'll cover this in more detail later. For now, in this video, you will also learn how to showcase the use of stateless and stateful examples by focusing on data flow. Imagine that data is money, and that money is controlled by your employer. This money can be considered props. This money props is passed to you and becomes your money state. The money props always flow from your employer to you, never in the opposite direction. In React, data is passed down from a parent component to a child component via props. A child component can't mutate or change its props. It can only read them and re-render. This means that the data comes from the parent and is just consumed in the child component. However, if this was always the case, then all you'd have in a React app is separate pieces of the DOM, acting as component templates to be filled up with the data they receive. While this works great, there'd be almost no interactivity. You've learned about passing data to a child component using props. However, there's another way to work with data in React components, and that data is referred to as state. All the data in React can be divided into props data and state data. Props data is data outside the components that it receives and works with, but cannot mutate. State data is data inside the component that it controls and can mutate. It also helps to think of it like this. The props data belongs to the parent that renders the component. The state data belongs to the component itself. To demonstrate this, let's open up VS Code and work through an example. I've built a new app using create React app. I have two files created, app.js and child.js. The app.js file defines the app component using a class definition instead of a function. When it's created, it initializes its state with a current date. The render function then renders a component called child. The child component has a prop named message defined, and its value is set as the current dates from the component state converted to a string format, which includes the hours, minutes, and seconds of the date. In the child.js file, the component renders the message prop in an h1 element. Now, when I run the app, the state of the app component flows its data down to the child component props, and the h1 element will display the current date and time. Well done! You have now learned how children and data flows in React.js, and you should also be able to showcase the use of stateless and stateful examples by focusing on data flow. By now, you've probably already learned about some important and useful core concepts in React. At this point, you're ready to learn how to add interactivity, maintain state within a React component, and explore hooks. In this video, you'll be introduced to what hooks are, how they can be used, and why they are useful. As you progress as a React developer, you'll likely soon use complex components with stateful logic. Keeping track of state across components can become quite a task, and this is where React hooks can help. One key benefit of hooks is that they solve the problem of unnecessary code reuse across components. Let's find out how they do that. Hooks are functions that were introduced in React version 16.8. They let you hook into React state and lifestyle features from components. Let's observe an example hook. Specifically, you'll examine an instance of the useState hook, as it's the most commonly used one. This hook is used to manage the state within a component and keep track of it, and it's built directly into React. To use it, the first thing you need to do is import the useState from React so that it's available for use. The next step is to declare a state variable within a component. You can provide any name to the state variable and the setState function. For this example, let's call the state variable showMenu and the setState function setShowMenu. If you've learned JavaScript, this syntax may feel somewhat familiar to you. You are probably wondering what exactly this code does. Well, it's actually doing something that you've likely encountered before. Notice that the convention is to name the state variable and the setter function using array destructuring. When you declare a state variable using the useState, it returns a pair which is an array with 2 items. Without array destructuring, the code would be long and cumbersome. Since it's more confusing and tedious to access the array items by index, array destructuring is preferred, and it significantly simplifies the code. You now have a new state variable called showMenu. The useState then sets the initial value of showMenu as false. So to summarize, calling the useState hook does 2 things. It creates a state variable with an initial value that represents the current state, which in this example is showMenu, and it creates a function to set that state's variable value, which in this case is setShowMenu. The function setShowMenu is used to update the value of showMenu by passing the Boolean value to it. It does not matter what names you use for the state variables. You can define them based on your component and use case. The useState hook should be called at the top level of your component. In this example, notice that the useState hook was used to track the Boolean state value. You can use the useState hook to track any type of data. It could be strings, numbers, arrays, Booleans, or objects. For instance, you can even track the number of times a button was pressed. In addition to the hooks that come out of the box with React, you can also build your own hooks which will let you extract custom component logic into reusable functions. This is an excellent feature and benefit of using hooks. The biggest benefit of hooks is the readability and simplicity that they provide to the code. In this video, you learned the basics on React hooks and explored the useState hook. You now understand the benefits of using hooks and how you can use them within your React applications. Consider the different modes in an alarm clock and the situations you would use them in. Typically, you have alarm on for setting a time to wake up, alarm off for when this feature is not needed, and snooze for sneaking in a few extra minutes of sleep. Setting these modes doesn't require adding anything extra to your clock. They are built-in features that can be set with the push of a button. If you create this feature in a React app, you could create a component named clock and then pass in the status values via props. Recall that props is a feature of React that essentially allows you to hold information about the UI in the browser. In React, you also have another way to do this by using a similar concept called state, which also allows you to easily change how the component behaves in order to suit a given need. By the end of this video, you'll be able to describe what state is in React and why developers use it to control what is displayed in the browser from a component. It helps to think of state as a component's internal data that determines the current behavior of a component. And it's often used to store data that affects the behavior of a component. State is important because it allows components to stay in sync with each other and ensure that your app behaves as intended. For example, if one component updates its state, all other components that depend on that state will automatically update too. This means that a component sends its state to its children by using props. If the child components have their own grandchild components, then the child components might have some states that they send as props to those grandchild components. In React, state is kept in a state of variables. The main way to change state is to alter these variables. When a component is created, it gets an initial state. The state is used to initialize the component's properties. Components can be either stateful or stateless. But what exactly does that mean? To gain a better understanding, let's explore an example of each. First is an app component with no state defined. It performs a single action, which is to render the text a stateless component. And then you have a stateful function component. This component also renders some text, but it references a variable to do so. You'll explore how that works a little later. For now, notice the syntax used in the first line of the app's function body. If you're familiar with how array destructuring works in plain JavaScript, this line of code might already make sense to you. But to make things clear, consider an example array called fruits, which contains the three strings apple, pear, and plum. With its ES6 version, JavaScript introduced the concept of array destructuring, which allows you to assign several variables from the array using a single line of code. In other words, you can assign apple, pear, and plum to the fruit 1, fruit 2, and fruit 3 variables quickly instead of one at a time. With this in mind, let's come back to that line in the stateful component. Notice that the syntax used is similar to the array destructuring example you just examined, but with an interesting bit of code. React.useState. Hooks allow developers to hook into some otherwise inaccessible functionality. For example, to access the state object, you would use the useState hook. To better understand what is being destructured in the app component, let's call a console log to the useState hook. The output reveals an array holding two things, the string hello and a function. In this case, hello is the state value assigned to the word state variable. The function is a built-in one that is not declared. The function can be destructured with any name you'd like, but there is a convention to follow. If you set the state's variable name to be greet, then the destructured state function should be setGreet. This is because the second destructured variable is a function that will be used to update the state of the variable. So, let's examine an updated version of the stateful function component. Notice that the setGreet variable is not actually run. That is something that is done elsewhere. Later in this course, you'll learn about how you can extend this code with a clickable button to update the state. In this video, you learned about state in React, specifically the characteristics of stateful and stateless components in an app. Why do we use state in React? Because it's one way to deal with data in our React apps. State is a powerful tool in React that developers use to manage data that is likely to change in an application. Recall that the state data is internal to the component itself. This allows the component to re-render based on the changes in the state data and present the newest updates to the user. With that in mind, let's explore how you can update a component with the useState hook that you encountered earlier. The useState hook allows a component to define and track state. It does this with two arguments, the first of which accesses state and the second of which updates it with a function. For example, you can use the date variable to access the date state, then use the setDate function to update the state. To help you understand how useful the useState hook can be, you're now going to explore an example that demonstrates how to use it to observe and manipulate the state of a component. Let's observe an app that was made for a Mediterranean restaurant called Little Lemon. It has a header child component which receives the props and the object. It also accesses the message property before it returns it and renders it as an h1 element. In the parent app.js component, I import the heading component and I set the word as a state variable, set to the string of eat. For now, I ignore the comment after the eat string. In the return statement, I wrap the heading component in a single div. I pass the message prop of word plus and then in double quotes, at little lemon, all wrapped in an opening and closing curly brace. You already know that an opening and a closing curly brace signifies a JSX expression, which means that all the code inside of those curly braces will be evaluated as regular JavaScript. The JavaScript engine takes the word eat and concatenates it to the words at little lemon. Thus, in the browser window, I get the words eat at little lemon. If I want to update the value of the word state variable to something else like drink, I could use the setWord function directly to help me achieve this. However, when I save the change and run my code, the app does not work. This is because one can't use the state setting variable from your state directly. Instead of updating it directly, I can update it based on a click event. So I have another element called button, and onClick is equal to handleClick. I now set another function which I'll name handleClick. Inside the handleClick function definition, I run setWord to drink. I click File Save All and wait for the app to compile. Now when I click the Click Here button, I get drink at little lemon. To observe and update state, you can use the state setting functions and state variables using the state hook. But you must make sure that you use event handling attributes in JSX syntax or some other approaches, which you'll learn more about later. In this video, you have learned about state change basics in React, including how to apply the use state syntax to observe and manipulate state in components. Well done. As React applications grow in complexity, so too can the complexity of managing state across components. As a result, developers need a way to manage state in their application. In this video, you'll learn how to describe the concept of managing state and explore some of the solutions to managing state in React applications. To illustrate a scenario in which state needs to be managed, consider a small React app that helps promote a healthier lifestyle by allowing the user to monitor their food intake. This app tracks a daily meal plan, and the user can click on each individual meal as they've consumed it. The app then updates to show how many meals that are still left to be consumed for the day. The app consists of three components: a root component called app.js, and then two child components, meals list and counter. Let's explore each component in a little more detail. First, the app component imports the meals list and counter component and renders them on the screen. Next, the meals list component uses useStateHook to list a day's meals which are stored in an array. The array elements are saved inside the today's meals variable. Then the meals state variable is initialized to hold this value. In other words, the meals state variable holds the array. Finally, the counter component tracks the number of meals that a user is allowed to eat today. While this code and component structure may look good, there is a bit of a problem. The counter component needs to get state information from the meals list component, but both components are rendered by the app component. In other words, the meals list and the counter component are siblings and not in a parent-child relationship. This brings up a question. How can you pass the state information from the meals list component to the counter component, as the counter component is not a child of the meals list component? Let's explore a possible solution. First, you can simplify the meals list component by extracting the returned value into its own component. Then you can work with the separate components to display different meal items. So let's call this new component meals item. To do this, you can use the practice known as lifting state up. This means that you move the state from meals list up to the app component. Then you can pass state through props using the meals list component as a sort of bridge to the meal item component. And then you just have to count the data available in the counter component. The state has now moved up to the app component, and my meals list component becomes a conduit for the state data to be passed to its destination, the meal item component. The question you must now ask is, what is wrong with prop drilling? Prop drilling is a commonly used term to describe having to pass state through props in several layers of components, from the parent to the child to that child's child, and so on. Note that if the source data changes, you will have to transfer those changes across the entire prop drilled structure. This complicates things because state updates go to all the child components and their siblings, which then need to be updated to reflect this state change. Additionally, the problem gets bigger as the app grows, and you'll potentially have a huge amount of state being kept in the app component. Keep in mind that most of that state is not really supposed to be in the app component. That is because that state is about components such as the meal item component. There's another way to phrase this problem through the viewpoint of global state. Whenever I have state that might have to be used in various places in my app, that's a global state issue. An elegant solution for this issue is React's Context API. One way to think about the Context API is that it cuts out the middleman. There's no need for prop drilling and lifting state up. Instead, the component that needs the data simply gets it from the Context API. The way that this is achieved is by extracting the state into a separate file that holds the state in context. Then, any file that needs it simply imports it and uses it. Great job. You should now have a great understanding of managing state in React. During this course, you've probably learned a few approaches for managing state between a parent component and a child component. But have you wondered how well these approaches still apply for more complex apps with multiple levels of components? Fortunately, there are tools available to help you do just that. By the end of this video, you will understand how Context API can be used to manage state more efficiently across multiple levels of components. You'll also be able to perform basic state management using the useContext and user-reducer hooks found in Context API. By this point, you're probably familiar with the practice of passing state from one component to another by using props. While passing props helps to manage state, it is like taking a bus and going through each stop before you get off at the end. In comparison, using the Context API is like teleporting to your destination instantly. It's a way to bypass the redundant passing of data through multiple levels of components. Remember that API stands for Application Programming Interface. An API provides a predefined set of ways you can interact with some code. The Context API thus provides a streamlined way to work with context in React. To set it up, you need to add a piece of code that will be your context provider and is also where the state will be stored. When a component needs to use the state, it becomes a context consumer. Now let's examine a simple app that utilizes the Context API to control state. In my app.js file, I'll use some code for a starter setup, and you can also find this file in the additional resources if you'd like to use it to practice working with Context API. In the app component, I have import statements for meals provider and meals list. The meals provider provides context state data and gives it to all the components it wraps inside the app component. Currently, it wraps two components, the meals list component and the counter component, which are between the div tags of the return statement. The meals provider component holds all the state, which is organized with the help of the Context API. First, I set the meals context variable using the react.createContext function. Next, I declare the today's meals array, which contains several food items saved as strings. I then code the meals provider as an ES6 function that accepts the children value. This value holds everything that will be wrapped into the meals provider component when it gets rendered inside the app component. The children value is just returned from the meals provider, wrapped into the meals context.provider JSX element. The meals context.provider JSX element comes with the value attribute, and this value attribute gets assigned the meals object, which is the value I set to the useState variable earlier. Before exporting the meals provider component at the bottom of the file, I'm also setting the useMealsListContext variable to the react.useContext call and passing it to the meals context as its single argument. This makes it easier for me to destructure the meals object from the useMealsList context variable. Finally, in the meals list component, I'm accessing the context state by importing the useMealsList context from the meals provider file. Let's break down how this component works in more detail. First, I'm destructuring the meals property from the objects returned from the useMealsList context call. The original object has a single property named meals, which holds an array of 3 meal strings. Once I destructure the meals property from that object, all I have left is the array of 3 strings saved in the meals variable, which allows me to map over the meals value, where I'm rendering an H2 for each member of the meals array. This code is probably more complex than most of what you have encountered. Don't worry if it takes time for you to understand how it works. Just remember the important part, that this setup gives you a nice starting point for working with the context API. And lastly, let's examine the counter component. Note that it gets the context data in the same way that the meals list component does. This is the usefulness of having a centralized state store. It allows me to simply reach into the state provider directly from whatever component needs it, without having to do prop drilling or lifting up state. Next, let me show you how the useReducer hook works. Let's move on to the useReducer hook. You can think of it as a superpowered useState. While the useState hook starts with an initial state, the useReducer also gets a reducer function in addition to the initial state. Let me illustrate that with a code example. Let's say I have a ride-share app that represents the amount of money in my wallet. The initial state is a value of 100, and the action of picking up a customer increases the value, while the action of refueling my vehicle decreases it. I've applied a reducer function, which takes in the state and the action. Instead of using setState like in the useState hook, I use the dispatch method of the useReducer hook, which accepts an object literal with a single property, type, set to a matching action.type, whose behavior is defined inside the reducer function. Now, when I interact with this app in the browser, I can increase the money value by clicking the A New Customer button, or decrease it by clicking the Refill the Tank button. In this video, you learned how the useContext and useReducer hooks can be used to manage state more efficiently across multiple levels of components. In life, there are rarely perfect solutions that suit every need. For instance, this concept applies when it comes to selecting a vehicle. A small car is usually more fuel efficient but has limited space. On the other hand, an SUV can handle many passengers but burns fuel quickly. Making the best choice starts with identifying your specific needs. This is no different when it comes to choosing stateful or stateless component in programming. By the end of this video, you'll be able to describe the differences between types of state and choose the best type to suit a given need, and explain how the dynamic nature of React causes structure decisions to influence complexity. The distinction between stateful and stateless components is that a stateful component holds state as internal data, and its state changes based on the way that the app is built, often as a result of user actions. A stateless component, however, doesn't store state, and any changes must be inherited through props. When deciding if a component should be stateless or stateful, you can refer to the following rules. Use stateless components when your component doesn't need to maintain its own state in order to work. Use stateful components when your component does need to maintain its own state in order to work. This might sound like an oversimplification, but let's explore why this general rule is enough. A common approach for organizing components in React is to have a stateful component as the parent, which then sends its state down to several stateless components that then receive the state and render it on the screen. The children components are stateless because they don't have their own state and only receive their parent state when passed down by using props. Keep in mind that you should never change the values of props in children components, as they are immutable. Now that you know the basic logic, let's break down a specific example of this approach in action, starting with two components, the app component and the child component, which returns a message. In the app component, the useState hook defines and keeps the state that will be passed to the child component as the props object. The app component renders the child component and passes the date to it in a string format as a prop named message. One thing to keep in mind, and something that is often overlooked by React beginners, is that a prop doesn't always have to pass state. In addition to state, JavaScript values and functions can also be passed to the child component. It's still data, but it's props data rather than state data. In the child component, there is an h1 element. The content of this element will be the message prop that is passed into the component. Note that props are not changed or updated in the component as they are immutable, meaning they can't be changed. Since the child component doesn't store any state, it is a stateless component. All of its data comes from the props passed into the component. The app component stores the state which can be changed through events and functions and is therefore a stateful component. In this video, you learned why and when to utilize stateful or stateless components in your React apps based on your specific needs. You also observed that although a stateless component can't directly pass state, it can still trigger actions that will update the state of other components. You've reached the end of this module, which explored the concepts of data and state in React. It's now time to recap the key knowledge and skills you've gained. Module 2 gave you an overview of the concept and practical use of state and stage management. In the process, you gained knowledge on how to handle events, and you learned how to dynamically change content on a web page. The first lesson was about dynamic events and how to handle them in React Native. You now know that every time you click or tap a button or scroll down a page, it produces events in the browser. And events are the process by which JavaScript interacts with HTML. You learned how to identify types of events and how to handle them using components. React can work with most of the same events found in HTML, but React handles them differently. This means that you may encounter unfamiliar errors when you run your event-driven React code. Thus, you learned about common errors associated with events and how you can deal with them. You also learned about the syntax differences for using event handlers in HTML and React, so that you can write event handling code using different types of syntax. Another important topic you covered are the different ways to embed expressions in event handlers in React. These methods include using an inline anonymous ES5 function, using an inline anonymous ES6 function, using a separate function declaration, and using a separate function expression. Then you moved on to learning how all the event handling concepts work together with state, styling, and the use of ternary expressions. To test your skills at dealing with dynamic events, you completed an ungraded lab where you practiced event handling by building a simple number guessing game. And that was the end of lesson 1. The second lesson was about data and events. In this part of the module, you learned about the React data flow hierarchy, like how data flows from a parent to a child component. In React, data flow is a one-way street. It starts at the root and can flow to multiple levels of nesting, from the root component to the subcomponent, and then the sub-subcomponent, and further down the hierarchy. This type of data flow ensures that the data is moving from top to bottom through the component hierarchy. It also ensures that changes are transmitted through the system. Next, you learned about state and how it relates to component behavior. All data in React can be divided into props data and state data. Props data is data outside the component that it receives and works with, but cannot mutate. State data is data inside the component that it controls and can mutate. Keeping track of state across components can be difficult, and this is where React hooks come in. Hooks are functions. One key benefit of hooks is that they solve the problem of unnecessary code reuse across components. For example, you can use the useState hook to track any type of data. It could be strings, numbers, arrays, booleans, and objects. The biggest benefit of hooks is the readability and simplicity that they provide to the code. You also learned about some common approaches for state management. For example, how Context API can be used to manage state more efficiently across multiple levels of components. You learned how to perform basic state management using the useContext and userReducer hooks found in Context API. After this, you were introduced to stateful and stateless components, and you learned how to choose the best type to suit a given need. For example, a stateful component holds state as internal data, and its state changes based on the way that the app is built, often as a result of user actions. A stateless component, however, doesn't store state, and any changes must be inherited through props. You learned some rules to follow to decide if a component should be stateless or stateful. These are: use stateless components when your component doesn't need to maintain its own state in order to work. Use stateful components when your component does need to maintain its own state in order to work. And finally, you've completed an ungraded lab that tested your ability to manage state in React. After completing this module, you are now able to identify some common errors associated with events and use the syntax required to handle them. Use an event to dynamically change content on a web page. Explain the hierarchical flow of data in React. Recognize how data flows in both stateful and stateless components. Explain the concept and nature of state and state change, and use common methods to manage state in React. In the upcoming module, you'll learn about working with links and routing, as well as using assets in React. This should finalize your preparations for coding your own portfolio project in React. Excellent! You've made great progress in your journey toward becoming a React developer. In the early days of the web, there were no true standards for design, which meant that developers were often very experimental. There were various designs and experiments, but ultimately, the web development community settled on a few best practices, and today, the web is a mature medium. In this video, you'll learn about the basic types of navigation on websites and how the navigation process works in React. Now, if you think about the history of web layouts and web navigation, it's like the development of other great inventions throughout history. For example, after the Wright brothers flew the first plane in 1903 in Kitty Hawk, North Carolina, there was a period of a few decades where engineers were experimenting with different designs. Planes with 2 or 3 sets of wings were the order of the day. Finally, after this initial exploration stage, airplane design settled down and the rules and best practices of building airplanes were established. Like the development of rules of airplane construction, after the experimental years of the early web, the web design and development community settled on a few accepted and expected designs. The focus in modern website navigation user interfaces is on utility. Stephen Krug's famous book on user experience, Don't Make Me Think, sums up the rule that developers are following today. It's your duty as a web developer and designer to follow the best practices that have already been established. For example, a steering wheel does not belong on a washing machine, or an old-style phone dial does not belong in a car. In the same way, you wouldn't want to confuse your website visitors by giving them navigation that might look and feel smart, but that's completely different from what they're used to. So you might be wondering, what is accepted modern website navigation, and how does it work in React? Website navigation is the part of any website that allows you to browse through various pages or links on that website from a single component. There are several practical implementations of this user interface pattern. Let's explore each briefly now. The most common navigation components are a horizontal navigation bar, a vertical navigation menu, a menu hiding behind a button, and a footer navigation menu. The horizontal navigation bar is often referred to as a navbar, and the vertical navigation bar is also known as a sidebar navigation. The menu hiding behind a button is usually represented by an icon that has 3 horizontal lines, and is thus referred to as the burger icon or the burger menu. An alternative to this is the drop-down navigation menu known as the mega menu. This menu is usually also hiding behind a button and is usually used as a sub or large menu on e-commerce sites and other sites that require many links. The footer navigation menu is usually displayed as several visual columns containing links. All these mentioned menu patterns can often be used simultaneously in different parts of the same page. Additionally, a more complex navigation UI can include multiple navigation approaches in a single component. You may, for example, have a horizontal navigation bar or navbar with drop-down menu items. If you're using a smaller resolution, the navigation bar displays as a burger menu icon. When you click on the burger menu icon, a mobile sidebar or a vertical menu appears. Okay, so now you're familiar with some of the navigation types that are available in your React apps. Let's explore how they are implemented to load different pages. If you compare the navigation of websites built with React against HTML and CSS, you'll likely find no visual difference. While visually everything looks the same, in the code, React deals with navigation between pages differently. This is because the entire app is loaded inside a single div, so you're not actually visiting different pages like you would with hyperlinks and HTML files. Instead, the content of that single div is controlled by React, and it's based on changes to the virtual DOM. It either updates the existing view or loads a completely new view, giving the user the impression of visiting a completely different URL. Recall that with HTML, developers can use a list to make a navigation menu. Each list item contains a hyperlink to an HTML file. Then, some CSS to style the menu, like the display inline property to make the list display horizontally. To help illustrate how navigation between pages works with React, think about how the buttons on the inside of an elevator work. Pressing the button will take you to the selected floor. Similarly, each link on a website takes you to a different page if you click on it. If, however, you're in a React elevator, it's as if the elevator never moves. Instead, when you press a button in this React elevator, the entire construction of that given floor is injected into a single floor of this impossible building. That means that React by itself only takes care of the visuals of a single page, but has no notion about navigation between pages. However, this functionality is not available to developers from the React library itself. In order to achieve this illusion of a multi-page website, you need to add the React Router library to your React projects. Once again, you add this using the import statement, and you'll learn more about how to do this soon. Well done! In this video, you learned about the basic types of navigation on websites and how the navigation process works in React.
By the end of this video, you'll know how to install the React Router library on your machine, which gives you more tools for setting up navigation in your apps. You also practice using this library to create a basic navigation for a web page. Let's examine a starter app that I've already prepared. It has two components, which are named Homepage and About Me. Currently, Homepage is written to display the header text, "Welcome to my site," on the page. The About Me component displays the header text, "About Me." Both components are children of the app component. Notice that Homepage and About Me are both imported into the app component and referenced using anchor tags. However, with the default React library, these anchor tags won't work as expected. This is because React can't imitate multi-page websites. However, I can make this possible with the help of another library known as React Router. As you may have guessed from the name, React Router gives you more control over the routing of components. I'll install it using the npm command npm I react-router-dom @6. To confirm that it's available, I inspect package.json and find the new entry in the dependencies, which is React Router DOM 6.3.0. Now that React Router is installed, I'm ready to make my broken links work. First, I'll access the index.js file and enter a statement to import browser router from React Router DOM. Once I've imported it, I need to wrap the app.jsx element inside browser router by placing it between the browser router tags. With that done, let's return to app.js. Here I need to import routes and route from React Router DOM. I also need to replace the child JSX elements with some different code. Homepage becomes route path equals and then / between double quotes. This is followed by element equals and then the homepage JSX element inside of curly braces. Note that the route tag is self-closing and has no children inside. For about me, I add a similar line, but I'll add about-me after the /. These lines will also be encased between route tags. If I go to my browser and type the exact link on one of the routes, for example, /aboutme, I'll get only the About Me component showing under the navigation. However, if I remove the About Me from the URL, in other words, if I open the root route that is represented with a /, then it'll show the text from the homepage component under the navigation bar. Notice that I'm grouping all the routes by wrapping them inside the routes JSX element. Also, note that the nav tags are outside of the routes tag, meaning that navigation is outside the routes. Finally, I need to replace the anchor tags with React router links. This allows the correct component to be loaded when the link is clicked, rather than simply refreshing the page. So in the app component, the anchor tag for homepage becomes link to equals and then the / between double quotes. This is followed by class name equals and then nav-item in double quotes. For About Me, the change is similar, except that About-me appears after the /. I also need to import link from React Router DOM and save my changes. Now when I click on either of the navbar links, the correct content loads in the browser. In this video, you learned how to install the React Router library and utilize some of the key functionalities to create a navbar. Now you're ready to learn about more efficient ways for users to navigate your apps.
By now, you should be familiar with the concept that React dynamically changes web page content. For example, you discover that when a React website changes from homepage text to About Me text, it isn't going to a new page, it's rendering one component instead of another. While this is useful, you need to give React very specific instructions about what and what not to render. And when you have components that are responsive to events such as clicks, this can add another layer of complexity. Fortunately, there are several approaches for writing the logic to ensure that this process goes smoothly and requires less work from you. By the end of this video, you'll have a high-level understanding of conditional rendering and know how to set it up using ternary operators. Recall that state is a component's internal data, which that component can control or change, as opposed to props, which the component receives but cannot alter. In an app, you can render components conditionally based on whether a specific state data has specific values. In other words, when you write the rendering logic in the main app component, you'll need to reference the state of the other components. For example, suppose you have a component that contains code for a button that shows a sidebar. The button controls the state of the toggle sidebar variable, which is set to false. When the button is clicked, the state of the toggle sidebar variable is updated to true, and the sidebar component is displayed. To make this possible, React works with conditional concepts and syntax that are already available in JavaScript. For example, recall the conditional if-else statement in JavaScript. Developers use it to run code conditionally based on whether something is either true or false. To illustrate conditional rendering in action, let's first consider an example productivity app. Based on the device's date at the time of access, the app displays one of two messages. For workdays, the message is "Get it done." For weekends, it displays "Get some rest." As a developer, there are a few ways you can achieve this functionality in React. But in this video, you'll focus on using the ternary operator to write simplified if-else conditions. You start by creating a component called currentMessage. This component uses the built-in date function in JavaScript along with the getDay method to store the day of the week as a number, where 0 represents Sunday and 6 the following Saturday. Next, you create the two components that each hold one of the messages to be displayed. Let's name these components workdays and weekends. The currentMessage component needs to render the appropriate component based on the value returned from the getDay function call. Let's set up the conditions to make that happen. Recall that the ternary operator takes 3 commands. First is the condition, which in this example uses the logical AND operator. The condition checks if the value stored in the day variable is greater than or equal to 1 and less than or equal to 5. Then the question mark symbol, followed by the expression to execute if the condition evaluates as true. In this example, the component workdays is rendered. Next is the colon symbol, which represents the code to be executed if the condition evaluates as false. And if this happens, the component weekends is rendered. Using the logical AND operator in the condition means that both expressions have to return true in order to render the workdays component. Otherwise, the weekends component will be rendered. While using the ternary operator is a common pattern that you'll see in React code, if you are new to React, it may be difficult to understand what's happening. So let's refer to a simpler version that uses Boolean values. In this example component, is it summer yet? The variable summer is set to a value of true. A ternary operator returns the expression after the question mark if the condition before the question mark is true. Otherwise, it returns the expression after the colon symbol. So since the variable summer evaluates to true, rendering this component will return the string "let's go to the beach." In this video, you learned about conditional rendering and how to implement it within dynamic apps by using ternary operators.
By the end of this video, you'll be able to describe the various approaches to conditional rendering in React, and you'll be able to use the if-else statements and ternary operators to render components conditionally. I used the Create React app to build a starter React app. I'll go through the code in this customized starter app to demonstrate some conditional rendering in practice. The goal of my app is to use the local computer's time and based on the returned values, output various messages inside the same return statement, all wrapped in a single div element. Specifically, I want to code a small app that displays a message for a given workday, and if it's morning time, ask the user if they've had their breakfast yet. I start my app component code by declaring a time variable and assigning the call to the date constructor to it. I then set the day variable, and I use the built-in toLocale string function that exists on the date object to specify the locale as English US. I also specify the weekday value as long, which displays the days as full words such as Monday, Tuesday, Wednesday, and so on. Next, I declare a morning variable that stores a Boolean value based on whether the current time is greater than or equal to 6 and less than or equal to 12. Finally, I declare a day message variable, but I'm not assigning any value to it yet. To generate a dynamic message, I use an if-else statement passing it the value of the day variable. I also make all the characters in the day variable string lowercase with the help of the built-in toLowercase function. Based on the value stored in the day variable, I then assign a specific string to the day message variable. For example, if it's a Monday, the day message variable stores a string that reads Happy Monday. If it's a Tuesday, the string reads Tuesday, 4 days to go. After I've covered all the possibilities from Monday to Friday, I add the else statement with a string value for all the other possibilities. The string reads, stay calm and keep having fun. This brings me to the return statement. In the return statement, I have a single heading, h1, and inside of it, I'm accessing the string value stored inside the day message variable. Additionally, I use a ternary operator to conditionally evaluate the morning variable. If true, I output a string that reads, have you had breakfast yet? This string is placed inside a heading 2 element. If false, an empty string will be displayed. Notice the output of this code, Happy Monday. If I change the getHours value from 12 to 19 and save my code, notice that a new message is displayed underneath the heading that reads, have you had breakfast yet? That's all it takes to build quite a dynamic component that conditionally renders various kinds of strings in its return statement. In this video, you learned about the various approaches to conditional rendering in React using the if-else statement and ternary operators to render components conditionally.
By now, you should be familiar with creating React components and adding text to them. But text will only go so far in an app, and users expect things like images, video, or audio for a more complete experience. Fortunately, you're here to learn about assets and how to use them to liven up your app. By the end of this video, you'll know what assets are and how developers keep them organized in React. You'll also learn some of the common ways to import asset files to be used in your React apps. Let's begin by making sure you fully understand what developers mean when they mention the term assets. In React, assets can be things like images, style sheets, fonts, media files, or basically any file that's needed by your app at runtime. In other words, assets are all the files that your React app needs to have access to in order to work as intended. For example, you might code your app to display specific images or use certain fonts. But if you run your app without these being available, it might exhibit unexpected behavior, such as displaying a placeholder or using a default font. That's why it's important to keep assets easily and readily available to your components. A common way to do this is to add an assets folder inside of the source folder and keep all your app's assets there. Some assets can also be placed inside the public folder. For example, in the default React installation, you'll find that some images such as favicon and logo 512 are stored there by default. The general rule for asset storage is that if your app can compile without it, you can keep it in the public folder. For instance, favicon is in the public folder because no component depends on it. In other words, React doesn't need to use the favicon file to compile all the components into an app that will get served in your local browser while you're building your app. However, suppose you have an image that needs to be imported into one of the app components, then it's best stored in the assets folder. Now you're familiar with the concept of assets in React. Let's explore how to use assets. Suppose you're a developer working on an app that helps people adopt animals in their local area. You have built most of the app's components, but you are waiting on the adoption center to send you pictures of the animals that are looking for a new home. In preparation for this, you create the assets folder in the React application. The pictures arrive and you place them inside the assets folder so they can be added to your components. To add an asset file to a component, you first need to import it. This can be done with an import statement. For example, suppose this component will display a picture of a cat. You type the keyword import followed by the name you want to give your asset. You can call this almost anything you like, but it's best to stick to something descriptive that describes your asset. For example, cat. Then you type the keyword from, followed by the path to your assets. In this case, it's a file named cat.jpg, located in the assets folder. The next step is to create the function and write a return statement. Inside the return statement, you use the image tag and then set the source attribute to reference the asset name, which is cat in curly braces. Alternatively, instead of the asset name, you can reference the path to the assets folder relative to the component. You can do this with the require keyword, as well as curly braces that encase the JSX expression and act as delimiters. It's important to know that with this method, you no longer need the import statement. This is because you're using the required syntax right inside the JSX expression that's assigned to the src JSX attribute. In this video, you've learned what assets are in React and the best practices for storing them in your project folders. You've also learned some of the most common ways of importing and using image assets in your React apps.
In this video, I'll demonstrate various ways of displaying images. You'll learn 3 different ways to display an image in React app, specifically by using the import statement, using the require function to set the file path, or by providing an image URL. To demonstrate how you can work with embedded assets, I've created a basic app called Embedded Assets. In my app's source folder, I added the assets folder, which also contains an image folder. Notice I've added one JPEG image to the images folder named Central Park. To view the code of the app component, I click on the app.js file. Notice that the starting code of my app component just renders some text that describes the task at hand, which is to display 3 images with some styling. For this, I'm going to demonstrate the 3 distinct ways to import images in React. The first way is to use the import method, and I want to demonstrate how you set a name for your imported image. To import the image file Central Park, I type import rooftops, and then // to provide a relative path to the file enclosed in double quotes. In this example, my file is in the images folder inside the assets folder. Next, I'll render this image as an image tag. In my code, I use the height attribute to limit the size of the image by making its height exactly 200 pixels. I'm setting the source attribute to the value of rooftops, which contains the path to the image file. Finally, for best practice, I add an alt attribute with a basic description of the image. I save my file and notice that my image now displays in the browser. Okay, so that's one way to import an image using the import statement. The second way to import an image is by using the require keyword. To do this, I create this image with an image tag like I did before. Again, I limit the size of the image by making its height exactly 200 pixels, but this time I set the source attribute to require. I pass in the relative path of the image to the require function. The path is passed in as a string data type, so that's why the path is enclosed in double quotes. Once again, to finish my image code, I add a description of the image to the alt attribute. I save my code, and the second image now appears. Notice that with this approach, I don't have to import the image. I just require it and provide the string with the relative path to the image. Now I'll demonstrate the third way to import an image asset by loading an image file hosted on the internet. Instead of a local file, this time I want to display a random image URL from a photo hosting website. To do this, I create a variable by typing const, then the variable name random image URL, then I use the equals operator followed by the URL for the random image. I can now add my third image element inside the return statement. To do this, I add random image URL to the source attribute. So there you have it, the 3 different ways to use image assets in a React component.
Since the introduction of the smartphone and high-speed Wi-Fi, we now enjoy creating, consuming, and sharing video and audio content daily on our devices. By the end of this video, you'll learn how React developers use audio and video assets within an app. You'll also explore how to find suitable React packages to use when working with audio and video files. Let's begin by exploring a method to load a local video asset into your React app using just HTML. You can use the readily available HTML5 video tag to load a local video asset to your React app. Like loading an image or any other kind of asset file, you can just declare a variable somewhere above a component's return statement and then add it as a JSX expression to the src attribute. However, this approach might not work as easily with some major providers of video content, such as one of the several social media and social video sharing platforms. In that case, you have the option of rolling out your own solutions. This may be a bit more involved than just adding a video tag to an app. It might depend on the specific instructions on how a given social media platform recommends that you embed their video and audio assets into websites. Very often, you'd get a code snippet that you can copy and paste. However, a specific implementation might be slightly different because you would, for example, like to add it as a separate React component. You might be wondering, why do you want to prepare it as a separate component? One of the reasons is that you'd be able to easily switch one video with another by passing the unique ID of a given video as a prop. You can then control the video output that way. So far, you've learned about 2 ways of adding videos to your apps. The first method involves just serving a local video using the video element, and the second method is using embedded third-party videos. There's another approach you may consider, namely using a third-party NPM package to streamline the process of adding videos to your app. The NPM package ecosystem is huge. If you visit the npmjs.org website, you'll find millions of various packages. To make it easier on yourself, Type React Video in the search bar of the npmjs.org website to find some of the frequently downloaded npm packages. To choose the right one, you might want to check the frequency of updates. A package that's frequently maintained and has many contributors is usually a sign of a solid package to use. Additionally, make sure to check the package's GitHub page. Finally, you can also perform an internet search for the package name. These actions will help you make an informed decision on which package to choose. An example of a package that fits all these criteria is the React Player package. Visit the package's GitHub URL at github.com/cookpete/react-player. You'll find that the React Player package has over 6,000 stars, about 115 contributors, and that it's regularly maintained. So, what is the meaning of the stars? When a developer visits any repository on GitHub, they can show their appreciation of the project by clicking the star button. This is known as starring a repo. This can be done for various reasons, but if a project has been starred many times, that's usually an indication of its popularity. These are all good signs, so if you want a custom open source solution for your video needs in React, you can choose this package or a similar one. Great job! You now have a general idea of how to use audio and video assets in a React app, and how to find packages using npmjs.org and github.com.
By the end of this video, you will know how to install the React Player package and then use it to render a media player in React apps. You'll also know how to apply several common settings in React Player, such as automatic playback and the starting volume. Let's examine another app that I've created using Create React App. Currently, it's pretty basic and only renders an H1 heading that reads React Player Example. Let's make that heading true by adding in a video player. The first step of this process is to install the React Player module, and the second step is to import it into my app component. To install the module, I'll run the command npm install React Player. Once it has finished installing, the module becomes available to any component in my project, but only if I import it. So I'll use the command import React Player from followed by React Player in double quotes. Now I'm ready to add the imported React Player package as a component and render it from the app component. I also want to preset a few settings for the player, specifically to ensure that the video doesn't play automatically when the page loads and to have the starting volume at 50% of the maximum. To do that, I add some attributes to the React Player tag, playing equals and then false in curly braces, and volume equals followed by 0.5 in curly braces. For a complete list of settings, you can refer to the React Player's GitHub documentation. You may have noticed that the React component also contains the line URL equals vid_URL. This refers to the web link for the video, which hasn't been set up yet. So let's add that link to the vid_URL variable. Now that everything is set up, I'll click File and Save, and then verify that everything works as expected in the browser. I can play the video, use the built-in controls, and the video starts at half the volume, so it seems that everything is correct. Finally, you can find the project's GitHub URL at github.com/cookpete with a capital C and a capital P /react-player. This page contains an About section on the right in which you'll find a link to the live demo. On the linked page, you can select from several video sources and change the video settings such as playback speed, light mode, loop, and more. If you would like to know more about the React Player, I recommend experimenting with these settings and consulting the project's GitHub documentation. In this video, you learn how to install and use the React Player package and change common settings for the React Player.
You've reached the end of this module on setting up navigation, updating and using assets in React.js. It's now time to recap the key lessons you learned and the skills that you gained. In the module, you explored the basics of single and multi-page navigation, as well as the conditional rendering or changing of content in response to user status or choice. The first lesson covered linking and routing of components in React for navigation. Website navigation is the part of any website that allows you to browse through various pages or links on that website from a single component. And in modern website navigation, the user interface is all about functionality. You learned about the most common navigation components like the horizontal navigation bar or navbar. But of course, most websites have more complex navigation UI that include multiple navigation approaches in a single component, like combining a horizontal navbar with drop-down menu items. You learned that there's a key difference between the navigation of websites built with React versus those built with HTML and CSS. With React-powered web pages, called single-page applications or SPAs, the entire app is loaded inside a single div, so you're not actually visiting different pages like you would with hyperlinks and HTML files. That's because a single-page application or SPA comes with its own special implementation of anchor tags and links that give the illusion of loading different pages. To achieve this illusion of a multi-page website, you learn that you need to add the React Router library to your React projects, and you practice using it to create and implement a basic navigation route for a web page. In this lesson's ungraded lab, you used code from the lesson item titled the navbar, and you had to add another link to the existing code. After this, you learned about conditional rendering, which is necessary for React to be able to dynamically change web page content. As part of this section, you learned how to set up conditional rendering using ternary operators to write simplified if-else conditions. The second lesson focused on using assets in React. Here, you learned that assets are files that your app needs at runtime, like images, style sheets, fonts, video, or audio. You learned how developers keep assets organized in React, and about some common ways to import asset files. A common way to organize assets is to add an assets folder inside of the source folder and keep all your app's assets there. Some assets can also be placed inside the public folder. The general rule for asset storage is that if your app can compile without it, you can keep it in the public folder. In this part of the module, you learned how to use embedded assets and about the advantages and disadvantages of embedding assets, as well as about the trade-offs inherent in using asset-heavy apps. And in the first ungraded lab of this lesson, you learned how to add an image from the assets folder that had already been added to the src folder. What's more, you also learned more about using audio and video assets in an app. Here you learned how to find suitable React packages to use when working with audio and video files. And you learned about 3 ways of adding videos to your apps by serving a local video using the video element, using embedded third-party videos, or using a third-party npm package to streamline the process of adding videos to your app. Additionally, you learned what you can do to help you decide what package to use. You should check the frequency of updates, check the package's GitHub page, and perform an internet search for the package name. To help you become familiar with using such packages, you learned how to install a React Player package and use it to render a media player in a React app. And you learned how to apply common settings like automatic playback and starting volume. Your final ungraded lab of the module was to finish an already built app with the user interface that allows visitors to play bird sounds by pressing buttons. Now that you've completed the module, you should be able to describe navigation design in React with a focus on single and multi-page navigation, create and implement a route in the form of a navbar, demonstrate the conditional implementation and rendering of multiple components, explain the folder structure of a React project in terms of embedded or referenced assets, demonstrate how to manipulate image assets using reference paths, and use media assets such as audio and video with React. Congratulations, you've now covered most of the basic concepts in React, and you're ready to complete this module's quiz and review the additional resources for this module. There's just one more module left before you complete this course. In the next module, you'll apply your knowledge by completing a mini project in React by building a calculator app. In this course, you learned about the basics of working with React. Let's take a few moments to recap the key topics that you learned about. In the opening lesson, you received an introduction to React. During this introduction, you learned about React, became familiar with how React is used in the real world, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned about React components. In this lesson, you learned how to explain components, their architecture, and how they are rendered. Create components and update them using JSX. Describe how folders are structured in a React project and how this benefits development. And you then demonstrated your knowledge of how to import components. In the next lesson, you explored how to use components in greater detail. This means that you can now declare functional components with props and pass them to another component. Use JSX to add styling to components. Save styles so that they can be reused later, and embed JavaScript expressions in attributes. Next, you began the second module, which was focused on the roles of data and state in React. In the first lesson of this module, you learned about dynamic events and how to handle them. You can now identify the most common types of events. Use some common event handlers in your code. Use different types of syntax to write event handlers. And you demonstrated understanding of the concept of user-triggered events. You then learned about the relationship between data and events. As a result, you can now describe how data flows between parent and child components and explain the concept of state in React and how it is managed. You were also introduced to hooks and know that you can use them to extend the functionality of state. And you are able to identify some common use cases for stateful and stateless components. In the third module, you were introduced to navigation, updating, and assets in React. By completing the first lesson, you can now identify the basic types of navigation on websites, create a basic navigation route with a React router library, explain how components can be rendered conditionally, use several different approaches to set up conditional rendering logic. In the final lesson of this module, you explored assets in React and how to use them. You can now explain what assets are and the best ways to store them. Use assets that are embedded in data files and use audio and video assets in your components. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. I'll now demonstrate how you can use React to build a simple calculator app that is able to perform addition, subtraction, multiplication, and division operations. I have some code for this app already written. However, because it's incomplete, it encounters problems when it compiles. The first problem is that useRef is not defined, so I'll import useRef to fix that issue and then press Ctrl S to recompile. The second problem is that the useState hook is not defined, so let's import that as well. And when I recompile once more, the problems should be resolved. So the structure of the app is there, but currently it can only perform addition, so I need to add the other functionalities. Let's start by examining what I have for the plus function. It runs the prevent default function on the receive event object, and then it invokes a function for updating the state variable. I can use this as a template for the other functions I will write, so I will copy and paste this code into the functions I've started. In the minus function, I update result plus number to result minus number, so that it subtracts whatever is in the input. In the times function, I update the same snippet to result asterisk number. And finally, for the divide function, I use the divide operator or / to make it result / number. Now I also have two functions called reset input, which sets the input value to 0, and reset result, which sets the result value to 0 as well. Reset input needs to run prevent default, and I follow this with input_ref.current.value equals 0. For reset result, I use a different approach. I have it run prevent default, but then instead of setting the value to 0 directly, I have it multiply the previous value by 0. I type this as set result followed by an arrow function that directs prevval to return prevval times 0. Now if I go to the return statement of the app component, I find that I need to add the value of the current total as a JSX expression. So I type result. I can condense this code to a single line, so I'll do that. Next, I have to add buttons to trigger the functions that I've written. I paste in 5 button components that I've written previously, each of which is bound to an on-click event. This component is written for the plus function, so that is already taken care of. I'll update the other button components by changing the function that is called for each one, as well as the text displayed on the button. So the second button calls the minus function. The third button calls times. The fourth calls divide. The fifth one calls reset input. And the final button calls reset result. Now I press Ctrl S to save my changes. I'm ready to test out my app, so I type 2 in the input field and then click on the Add button. The result changes from 0 to 2, and then adding 2 again updates it to 4. Next, if I type 1 and then click on Subtract, the result becomes 3. If I enter 10 in the input field and click on Multiply, I end up with 30 as the new result. And now if I type 6 and click on Divide, I get a value of 5. Finally, I can click Reset Input to set the value in the input field to 0, as well as click Reset Results to clear the result and bring it back to 0. And that's it. My code is complete and my app works as per the requirements. You've reached the end of this React Basics course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your React journey. You were able to demonstrate some of this learning along with your practical React Basics skill set in the lab project. Following your completion of this course in React Basics, you should now be able to create a simple calculator app. Your calculator should be able to perform the 4 basic mathematical operations: addition, subtraction, multiplication, and division. The lab not only gave you the practical experience you needed, but it also has another important benefit. You now have a fully operational calculator built in React that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. So, what are the next steps? In this course, you were introduced to several key topics that can help you on your learning journey. You probably realize that there's still more for you to learn. As you continue through the program, you will develop your skill set. So, if you found this course helpful and want to discover more, then why not register for the next course? And once you've successfully completed all the courses in this program, you'll receive a certificate that you can use to validate your achievements. The certification can also be used as a progression to other Meta role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. Meta certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.